Hello, everybody. Today I am going to actually collect the data for your lab, which has to do with the relationship between force and length of a spring. Now, my spring is on an apparatus behind me. It is actually a rubber band. And your force is going to come from these quarters that are in an envelope. And you're going to have to actually calculate the force because this is a mass in grams. And so there's another video where it shows you how to calculate the force in case you've forgotten. All right, so we're going to go ahead and take this and hang this from our apparatus, and we're going to collect data. The data is going to look like this. You're going to need a column for mass. I'm sorry, right over here. You're going to need a column for mass in grams. You're going to need a column for the length in centimeters. So that's these two columns, mass and length, or position, x is position or length. Then you are going to need to calculate the force, because what you're actually going to graph is force and length. Force will be your y-axis, length will be your x-axis. If you can graph it in meters instead of centimeters, that would be great. If you can convert it into meters instead of centimeters, we'd be happier with that. All right, so I'm going to go ahead and collect data. You guys need to write that down on a data table that you have drawn that looks like this, and then you're going to make it in your lab report. All right, there's my apparatus. You can see that right now I have the rubber band and I have a piece of paper that when I get my head right down close to it, I can see that that piece of paper is even with the rubber band. So that is 0. Right now that is 0, and I'm going to start putting some masses on there. The first mass I'm going to put on there is 91 grams, and then I'm going to measure the length. And the length, when I do that, is about, say it's about 1.5 centimeters. All right, so 1.5 centimeters, and a mass in grams of 91 grams. You need to make sure that's in your data table. We're going to put on another mass. Here's another mass. Again, it's another 91 gram mass, and that is hanging there. And that 91 gram mass makes it exactly well, I shouldn't say exactly, but 3.8 centimeters. 3.8 centimeters and 91 more grams. So that would be 182 grams total for your data table. And now I'm going to add another 91 grams. And this 91 grams, this time, when I measure that length, the length is right about 6.8 I'd say 6.7 centimeters, 6.7 centimeters, and that will be this time 91 more grams, which is 373 grams total on there. I'm going to keep adding here until I run out of time on my video. And so here's another mass. That's another 91 grams. And that 91 grams happens to have a length of right about 9.3 centimeters. 9.3 centimeters. And that would be 464 grams total, I believe. All right, and I don't know when this video is going to actually kick me off. It only lets me go for 5 minutes recording this video, but that's okay. One more mass, 91 more grams, and that 91 more grams pulls it up to 12.1 centimeters, about 12.1 centimeters, 0.1 centimeters. So that's an additional 91 grams, which I believe would be about 555 grams. All right, so that is what you're going to put in your data table, and then of course you're going to need to graph that. All right, so data table, graph, and of course eventually an equation with units. Okay, so look back at your other videos to show exactly what you're going to do with this lab, but this is the data that you have collected. If you need to rewatch this video, that's okay.